Okay, so we're reviewing the quadratic formula, which is x equals negative b plus or minus, that whole formula that you know. And our a value comes from the x squared term, our b value comes from the x term, and our c value is the constant at the end. And we use this formula to find out the x solutions to an equation. So in our first example, we're trying to solve an equation, so we're trying to find an x value that will make this equation true. And so to find those x values, we'll use the quadratic formula. So our a is the coefficient of x squared, which is 1. Our b is the coefficient of our x term, which is negative 6. Don't miss your negatives. And your c is your constant, which is 1. So the negative b means the opposite of b. So the opposite of b in this case is 6, plus or minus the square root. Always square b in your head. So take our negative 6 number, squared. It's always going to make our number positive. That number squared is 36. Minus 4 times an a of 1 times a c of 1. All over 2a. 2 times a is 2 times 1. So we go and we simplify. I always say simplify what's underneath the radical first. We're going to learn later that that value is called the discriminant, which is going to have a key meaning. So on our calculator, 6 plus or minus the square root of 36 minus 4 times 1 times 1 is minus 4. 36 minus 4 is 32 all over 2. Okay, now we just took a time out and spent some time simplifying radicals, and we have to do this here. The square root of 32. We would break up root 32 into root 16 times root 2, because we know that that has a square root of 4. So we're going to see 6 plus or minus 4 root 2 all over 2. And make sure the whole thing is over 2. And then if both terms, see, your numerator is a binomial. It's a 6 plus or minus another term. So it's 2 terms, it's a binomial. So if both of those numbers, meaning the coefficients, share a common factor with the denominator, we can simplify this further. So 6 plus or minus 4, 6 and 4 are both divisible by 2, so we can divide each by 2, and we get 3 plus or minus 2 root 2. And those are our 2 answers, which is very common for quadratics to have 2 answers. Sometimes we only have 1, we'll get to that. Sometimes we have no solutions, we'll get to that as well. The key that we just kind of overlooked up here, though, and you may remember, is that you can't choose A, B, and C for your formula until it equals 0. So this is a very big piece up here, and this one already equaled 0. On the next one, we're going to see that this does not equal 0 as it is presented. So we have to move some things around to get it equal to 0. So I'm going to subtract this 6x over to my x term that's already there, and add my 2 over, which will make x squared minus 10x plus 14. And now a is 1, b is negative 10, and c is 14. So I go into my formula. The opposite of b is 10, plus or minus the square root. B squared in this case is 100, minus 4ac, all over 2 times a, which is just 2. So the x answer for this will equal 10 plus or minus the square root of. Now my discriminant, 100 minus 4 times 14 is 44. 100 minus 4 times 14 ends up being a discriminant of 44 all over 2. 44 can be broken down into root 4 root 11, which will be 2 root 11. So let me go this way. X equals 10 plus or minus 2 root 11 all over 2. Both of these are divisible by 2. So 10 divided by 2 is 5, plus or minus 2 root 11 divided by 2 is just root 11. And those are your answers. Okay? Now, there's absolutely a graphical component with the quadratic formula. These solutions would be critical points in this function. And the same is true for these solutions, would be critical points in this function if we were to graph that function on our calculator. So here we're actually being given a function, and we're asked to determine the x-intercepts. And you all know from your flashcards that that's when y equals 0. So if we want to set the y equal to 0, that's f of x, we would just set that equal to 0 to find our x-intercepts. Oops, minus 36. So really, when we've been solving these equations, we have been finding the x-intercepts of the corresponding function. So if we were to look at a graph of this. So when we solve this by using the quadratic formula, the opposite of b is negative 4, so the opposite of that is 4, plus or minus the square root. B squared in this case is that number squared, 16, minus 4 times an a of 1 and a c of negative 36. All over, 2 times your a value of 1 is 2. So that's going to give us 4 plus or minus the square root of, our discriminant here is going to be 16 minus 4 times 1 times negative 36, 160. And how can we break down 160? I think 16 and 10. So root 16 and root 10 is the best we can do, because that is 4. So it'll be 4 plus or minus 4 root 10, all divided by 2, which is both divisible by 2, so we do 2 plus or minus 2 root 10. Express your answers in simplest radical form. So there they are. Now part B asks us to express those x-intercepts, because those are our x-intercepts. We would like to know where that actually happens, and nobody knows what the value of this is without a calculator. So they ask you now to express those answers to the nearest hundredth. So if I type in 2 plus 2 root 10, rounded to the nearest hundredth is 8.32. And then 2 minus 2 root 10, rounded to the nearest hundredth, is negative 4.32. So what happens here is on our calculator, or on our graph, 8.32 is approximately there, and negative 4.32 maybe is approximately there. And what we need to remember about parabolas that we learned in Algebra 1 is that if the a value, in this case 1, if the a is positive, if a is greater than 0, then the parabola opens up. So our parabola is going to do something like that and go through those 2 points. Okay? And what we also need to remember is our c value is our y-intercept. So actually, if this is negative 50, then negative 36 would have been down here somewhere. And I should make this parabola much, much steeper to catch the zeros and to get far enough down to that y-intercept of negative 36. And we could label that negative 36 as well. I apologize that the work is going over the graph. Okay. Now, if we want, again, now phrased a little bit differently, but the skill is still the same, which of the following sets represents the x-intercepts? Again, y equals 0. So we're going to make that 0. And use our quadratic formula. Opposite of b is 19. Plus or minus the square root b squared. So I have to do 19 squared, 361, minus 4 times an a of 3 and a c of 6, all over 2 times a. A is 3 here, so 2 times that is 6. So 19 plus or minus the square root. I'm going to get my discriminant here. That's 361 minus 4 times 3 times 6. 289 is my discriminant. And the square root of 289, I think I might know. I don't think that breaks down. I think it's just 17. So So it's 19 plus or minus 17 all over 6. Now there's two ways we go with that answer. We have to do the 19 plus 17 and divide that by 6, which gives us 6. Or the 19 minus 17, which gives us 2, and 2 divided by 6 is 1/3. And so if you look at your solution options, multiple choice, that would be option 4. Okay, the next exercise asks us to find the intersection point. So we are absolutely getting into systems. Intersection points, you should think systems, which again, we have systems in 3 variables, x, y's, and z's, which is always going to be elimination. And any other system is going to be a linear paired with something. So in this case, quadratics, since we're solving quadratics. So here's our line, here's our quadratic, and anytime we do these types, it's going to always be by substitution. And they say algebraically, which means we cannot use our calculator other than maybe to check at the end. And that's what they say. Then use your calculator to produce a sketch. Okay, so here's how substitution will work. You will always take your linear, and you will always solve for a variable. And in this case, y is already solved for. So since y equals 6x minus 3, we will take that 6x minus 3 and replace the y in the other equation, literally substituting it in. So this y, out with that y, and we'll replace it with its equivalent 6x minus 3 equals the 4x squared minus 6x plus 2. And quite clearly, now we just have to solve for x, and it will give us where those equations are equal. So get it equal to 0, subtract your 6x over, add your 3 over, which changes our equation to 4x squared minus 12x plus 5. So jump into the quadratic formula. The opposite of b, the opposite of negative 12 is 12, plus or minus the square root of b squared. That number squared is 144, minus 4 times a of 4 and c of 5, all over 2a. A is 4, so 2 times that is 8. Little work coming up with our discriminant. 144 minus 4 times 5 gives us a discriminant of 64. So 12 plus or minus root 64 over 8, which we all know the square root of 64 is 8. So it's 12 plus 8, which is 20 divided by 8, which is, let's see, 20 divided by 8 is 2.5. And then 12 minus 8 is 4 divided by the 8 is 0.5. So here's what we just did. Go back to the equation that we were actually solving. We were solving for the variable that you see in that equation. That is just an x. But when you're solving a system, you need the x-coordinate and the y-coordinate. So like we've seen before, these are just the x-coordinates. We solved x equaled those things. So 2.5 comma some y-coordinate and 0.5 comma some y-coordinate. And you have to go back and plug those x values in to probably the easier of the two, although no matter which one you plug into, you should get the same y value. I'll plug it into this one. 6 times 2.5 minus 3 will give a y-coordinate of 12. So 2.5 comma 12. And if I plug in 0.5, 6 times 0.5 minus 3, that one will have a y-coordinate of 0. So those are my solutions. And I did so algebraically. Now, checking on your calculator, you literally graph those two equations. So you can just watch here, 4x squared minus 6x plus 2, and 6x minus 3. And if I graph these, I'm going to see a parabola. There it is. I'm going to see a line. There it is. And it crosses once, and it crosses twice. This one might cross a little bit off my graph, might be a little bit further up. So I would go to my window. And if I want to see further up, I'm going to change my y-axis maximum. So, and actually since I know the answers, I know it's crossing at a y-axis or y value of 12. So I'll go up to 15 and that should be plenty. So again, there's my parabola. Here comes my line, and I will check by using my favorite menu, second trace, option 5, intersect. And my first curve, my cursor's blinking here. I'm going to scroll towards that, hit enter, enter, enter. There's my 0.50 answer. Got it. Second trace, intersect, scroll over here, enter, 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 and I get 2.5 with 12. There we go. Just as a side note, I have another system that you can write down, and it's another quadratic system. Quadratic there, the 2x squared. And here's a linear system as well, but see, the variable is not solved for here. So actually I should make this a little bit nicer. I'm going to make this equal to 6. Okay, so I always take the linear, and this one it was already solved for y, and I solve for a variable, whichever one's easier, and actually I'll even change it more. We'll just make it plus. So because y doesn't have a coefficient now, I changed it. I can solve for y, subtract 3x over, so y equals 6 minus 3x, and then kind of use that one instead. So now that y equals this 6 minus 3x, I would go back and I would plug that in for the y up there. So a little more substitution to get used to, but you'll see one on your homework where you have to get y all by itself on your own, and it won't already be done for you. Okay. Another thing, and I'll throw this sticky up here that I want to pay attention is sometimes, and it hasn't happened yet, which is why I wanted to point it out, is if you got your answer for the quadratic formula and it looked like this, and 2 and 3 are not divisible by 5, then this could be your final answer. Or sometimes you'll see them still split it up. You'll see them put the 2 over the 5 plus or minus the 3 root 15 over the 5. So that is possible. And also here's a different one where you might get this answer, and because the 2 and the 3 don't divide by 2, you can leave your answer like this. Or they will actually split it up and do 2 over 2, which is 1, plus or minus 3 over 2 root 15. So just be aware of final answers being able to be written in that fashion. Exercise 3 you should be able to try on your own. Just, again, do the quadratic formula. And then lastly, I want to get to this exercise, number 3. So we're given an equation that actually has meaning to it. P, it's going to tell us, is the P is the percentage of popcorn that gets popped as a function of T, the oil temperature. Okay, it says that we're revisiting another problem, but it's actually the first time we've seen this. So based on the temperature that it's cooked at, a different percentage of popcorn is actually popped. And we've seen a bag of popcorn. Sometimes there's way too many kernels left, and sometimes there's no kernels left, but it's burned. So the company wants to find the range of temperatures that ensures at least 50% will pop. So if they're giving us the percentage, they're giving us P is 50. So we would say 50 as our percentage. And we would solve this by subtracting 50 from both sides. Negative 394 minus 50 gives us negative 444. Okay? And we would go through the quadratic formula and solve that. You might want to change that into a decimal. I'm going to cheat, and I'm going to solve it via the calculator. So negative 1 over 250 x squared plus 2.8x minus 444. And if I graph this, now T is the temperature I'm cooking at. Well, first of all, think about your y-intercept. Your y-intercept is negative 444, so my window is not big enough. I'm going to go to negative 500 to 500. And then my percentage is my, oh no, yeah. My percentage is obviously 0 to 50%. The temperature I'm cooking at, negative 394, so maybe I just do negative 500 to 500 on both and see if I like my parabola. There it is. Okay, so it's going to turn around here. So they want the solutions, and the solutions are here and here. So second trace, these are my zeros now. So if I go left bound, and there's my cursor, so I'm going to bring it to the left of that 0, hit enter. Then it says right bound, go to the right of that 0, hit enter and enter. That's a temperature to the nearest tenth of a degree, said my problem. That's a temperature of 242.8 degrees. And then I'm going to have more than 50%, so it said at least 50%, so we're all good until over here, which is where we'd start burning too many. Second trace. Find your 0. Left bound. Right bound. Enter. 457.2 degrees. So anywhere in between those two numbers. So here, prior to 242 degrees, if it's not warm enough, we're going to have way too many leftover kernels. We're all good in here, and then if we are cooking it over 457.2, all our kernels will be popped, but we would probably have way too many burned pieces. So this is the temperatures from there to there that would give us at least 50% of the kernels popping.